talk about what we're looking at next here. So, okay, primitive data types. This is something which has been implicit in the loosely typed or non-typed languages you've probably been using, like both Python and JavaScript are untyped in the sense that variables can just be anything. There's been an implicit type because you've no doubt worked with variables that have both numbers as well as strings and arrays and objects and all kinds of other things. Java is a strongly typed language, and so every variable has to be one specific declared type, and it can only be that type. Operator precedence, that's something you've probably encountered, but each language has its own little quirks on that. They're mostly fairly standard. Look at assignment operators. Again, that's something you've used a lot before. And then finally, the scanner class, which is something new. And that's basically how you will be able to interact with the console. Okay, so the objectives of this class are to know what the Java primitive data types are. There are 7, and we're only going to be concerned with a few of them. You should be able to write expressions and assignment statements. That's something that you can do right now in your other languages. Understanding the operator precedence, that can be important in trying to figure out what a particular expression is going to produce. And in particular, there are times when you need to take a variable or an expression of one type and treat it like another. This is something which is done for you in other languages and which is not done for you in Java, so you have to be a little more explicit about it. The main gotcha on this has to do with integer arithmetic, particularly integer division. That's one of the big gotchas that you need to be aware of. And then this scanner class, which is how to read input from the console. Why are you not? All right, so 8 is 8 primitive. I said 7. I lied, there were 8. So, okay, so of these, the ones that represent integers, they have bytes and shorts. Occasionally, if we're delving into strings, we'll sometimes use bytes. That's going to be fairly rare. Most of the time, ints and longs, shorts are fairly useless. Floating point numbers. Now, there are floats and there are doubles. Why are you doing this to me? And for our purposes, floats are pretty useless. And the reason is because they do not provide the kind of precision that we need. Okay, char, that represents characters. We very rarely need that, but occasionally. And then Boolean variables, that's something which is extremely useful and something which we will be using. Okay, this is just an FYI that the storage size, again, that's these days when there are literally gigabytes of RAM, then, in the old days when computers were tiny, you really had to squeeze every last thing out of it. That's why things like this shorts and floats were hanging around. The thing to understand, though, are these min and max values. So in particular, we'll be using ints and longs for representing integers, and these are the possible values that they have. So, int this is a fairly big span of possible values, and sometimes it's just not enough. And so that in that case, you resort to long. Floats, again, the problem with floats is that they just don't have the significance that you want. So we will not be using those. Whenever there's a floating point, we will use doubles. You're not responsible for knowing what these values are. What you should know is that these values exist. That is, on the computer, you can't represent just arbitrary things. However, with a double, 1.7 times 10 to the 308 is a pretty big number. So that will handle most of your things. Okay, so characters. In some languages like, Python comes to mind. I'm not sure about JavaScript. They're a single quote and a double quote are equivalent. In Java, they are not. In Java, a single quote is used to just eliminate one single character. And notice that you can actually use a blank line here. We won't be working with characters that much, but there's something that they occasionally come up when we start manipulating strings. So Java was actually the first language to use Unicode. The previous ones used something called ASCII, which was very, very constrained. Unicode enables us to represent things like, the Cyrillic alphabet. There's many, many more different characters. For our usage, we won't go too much beyond basic ASCII's type of stuff. So again, here's ASCII, strict subset of it. This is what we kind of used before Unicode came along. And basically you have uppercase letters, lowercase, punctuation, digits, special symbols, and then the carriage return, tabs, etc., that we saw as our escape characters yesterday. Now, this is one of the Booleans are a very useful thing. A Boolean variable can either be true or false. And what's different between Java and languages like C is that in C, they don't really have Booleans. They have things that kind of look like Booleans, but they're really integers. And what they decided to save space or something is that an integer that was 0 would represent false, and an integer that was not 0 would represent true. And that turned out to have a lot of problems. So a Boolean can only be true or false, and those are the only valid types. And there are good reasons for that. Okay, expressions. So basically, when you take variables or constants and you combine them using operators, then you produce another thing. We've already seen an expression using strings when we concatenate them using plus. Arithmetic expressions they use those for numbers, and this is something that you've seen a lot of. Okay, so ever since kindergarten, we've seen addition, subtraction, and then in first grade, we learned multiplication and division, and then, the remainder, or modulo. Okay, so, but here's the thing to understand about these expressions. So if you have floating point values and you combine them with an operator with, say, integers, then the result is a floating point value. If you have just integers, whether they're ints or longs, then the result is an integer or a long. So if I add two integers together, then I will get an integer. If I multiply two integers together, I'll get an integer. If I divide two integers together, I'll also get an integer. That's the gotcha. So, let's look at this. See, 14 over 3 in the previous languages, you would get 4.6666 something. And likewise, darn. But, okay, remember that if you have an operation that consists of two integers, the result is an integer. And what Java does, and this is not a law of nature, but this is what they decided, it will truncate. It does not round, it truncates. So strictly speaking, 14 over 3 is like 4.6666, etc. But since these are integers, it will truncate and give you 4. Okay, that's the gotcha. That's the something to watch out for. Likewise, 8 over 12, that's 0. Okay, so now the remainder or modulo operator, 14 divided by 3, the remainder is 2. 8 divided by 12, the remainder is 8. Okay, so these are, and I assume you've encountered all these before, but again, the main thing to watch out for is integer division. Okay, so just as a check, well, if it happens evenly, it's 6, right? If it's, now notice that these are floating points, so the result is 6.0. So now these are two different things. This is the integer 6, this is the floating point 6. 10 over 4, that would be just 2, but 10 over 4.0, because of the 4.0, the result is going to be a floating point. So that would be 2.5. Okay, 4 over 10, that would be 0. 4.0 over 10, 4.0 over 10. Okay, well, there they are. So again, remainder.
That
0.
works too.
Question?
No, I was just saying that works too.
Sorry, my mouse is really giving me trouble today. Okay, operator precedence. And again, this is probably review, but if you haven't looked at it in a while, then it's important to understand this. But remember, I said one of my mantras is going to be throughout this course, and even the next one, where you, if you have that with me as well for the simulation, the prime directive is programmer intent. So this expression is not a good one. Now it's important, when you see an expression like that, it's important to understand that. But as a programmer, it's important to never write this. In other words, when you are programming, do not rely on precedence to dictate how the expression is going to come out. If there are only 2 quantities in the expression, then it's unambiguous. In this case, we have 4 quantities and 3 operators. So what is the intent here? And the reason I say this is a bad expression, not that it's incorrect. What is bad about it is that the programmer's intent is not clear. Now, it's important to understand the operator precedence. Multiplication, division, and remainder are evaluated before addition, subtraction, and string concatenation. So that's what you need to remember. And then arithmetic operators with the same precedence are evaluated left to right. But this is kind of the key. When you have more than one variable or quantity in your expression, always use parentheses to express your programmer's intent. So the way that this would be evaluated, because division has higher precedence than addition or subtraction, this would be evaluated first, so that you would have this quantity and then another quantity and a third quantity separated by a plus and a minus, and then they would be evaluated left to right. So this plus this minus this. But again, you should not do that. What you should do if you're writing this is always, you would put the parentheses here to indicate that, yes, this is exactly what you intended. And that you didn't simply kind of forget the fact that maybe this was what you intended. And if this is what you intended, then that expression is incorrect. So again, without parentheses, without explicitly showing what your intent was, this expression, while syntactically correct, is ambiguous as far as the intent goes. Okay, so just little questions here. Okay, so these are all plus. They all have the same operation, the same precedence, so they would be evaluated left to right. Okay, over here. All right, so here you have times and division that are of the same precedence, but higher than the others. So first, this would be evaluated, then this would be evaluated, and then they would be then plus and minus left to right. Whereas, okay, here, parentheses, these would be evaluated, then this, and then finally the whole thing. And then likewise, so the parentheses are evaluated from the inside out. So first this would be evaluated, then this, and then finally the whole thing. Okay, so assignment happens last. So basically when the left-hand side of an assignment statement always has to be a variable. And so what you always do is you always compute the right-hand side, however that does, and then store it in the left-hand side. Okay, again, you've been doing this for a while. Now, you've been doing this, but the right and left-hand side can contain the same variable. And so what happens is, because the right is evaluated first, then you would take so let's say if count were equal to, let's say count were equal to 5. Okay, so then what would happen? Well, first it would evaluate this, and this would be 6. And then that value 6 would be assigned to the variable count. Okay, overwrite. So when you execute this statement, the value of count is 5. When you execute this statement, it would evaluate the expression on the right and then assign it to the left. Okay, these are, plus, plus, and minus, minus. This was something that when these were introduced by C many decades ago, people kind of got all excited about it. There is only one context in which you are, I'm going to allow you to use the increment and decrement operators. And those are in for loops. And the reason is kind of a subtle difference between the two. Namely that the value of the these should never be used in a larger expression, because the value of this expression is different than the value of this expression. So therefore, the only place that I'm going to let you use them is in for loops, and we'll talk about what that. You've no doubt used for loops before. We'll get to what they are. The Java syntax for it is kind of weird, but it goes back. Java just basically duplicated C's for formatting for it, but that's just what they did, and it has it's a little weird, but okay. So now, just because these things kind of come up, we can combine operators and assignment. So for example, because a statement like this appears frequently, they decided that it would be useful to just kind of combine them into this. And that's okay, because again, these are both okay. Again, the prime directive, programmer's intent. If you see this, the programmer's intent is absolutely clear: to increment this expression, this variable, by whatever's on the right-hand side. It's equally clear what this is. So whichever you prefer, these are both fine. Again, whenever you're writing stuff, just sort of think of if somebody were reading this, would they understand with 100% clarity what it was that I intended to do? That's the criterion. Okay, so every operator can be combined with an assignment, and with the following, so if I combine if I have a plus, it's the same as adding the right-hand side to the left-hand side. If it's a minus, then it's subtracting the right-hand side from the left-hand side. Multiply the right-hand side. Divide. Again, because division is something that should always be looked at with suspicion because of the integer division problem. And then likewise, the remainder one. Okay, so with the right-hand side of an assignment operator, that can be as complicated as you like. So now just be a little bit careful. So here it's like, okay, here's a complex expression, and they're saying we want to divide the left-hand side by what this is. To me, this starts to get into a little bit of a gray area. Rather than doing this, I think it would be, if I were writing this, I would separate these into two different things. I would create just a variable to hold this, and then have the result be with that variable, just to make it absolutely clear what it was I intended. If you encounter a situation where you want to do this kind of computation and you do it this way, that's fine too. Okay, so and a lot depends on the type. As we notice that the plus operator is overloaded. So if I'm doing it with strings, then it does concatenation. And if I'm doing it with numbers, then it's with numbers. If I'm doing it with integers, then the result is an integer. If I'm doing it with floating point numbers, I can either get an error, or if the left-hand side is a floating point and the right-hand side is an integer, then it will kind of work. That has to do with this widening business. So here's a situation where you have a bunch of, let's say I have a bunch of integer data and I want to compute the average of those. Well, typically, so for example, what is the average number? If I roll one die, what is the average of the number of dots that show up? the average is 3.5. Just okay, so the number of dots is going to be an integer, but if I want to compute the average, I would do 1 plus 2 plus 6, etc. And the average would be, and I would divide by 6. But integer division would give me 3, which is not the correct average. So sometimes we want to treat integers as if they were floating points. Okay, so basically we can take a something like an integer and turn it into a bigger one. They talk about shorts and ints. Again, this is just to conform with what the book is talking about. We will never deal with shorts, so we won't worry about converting an int to a short. However, ints and longs. A long is wider than an int, so I can take an int and I can assign it to a long. However, I cannot take a long and assign it to an int. Why? Because a long could have values that are inadmissible for an int. A long has more possible values than an int does. And so the compiler says, oh, you cannot assign a long to an int. You can assign an int to a long because that will always be successful. Okay, so the 3 types of data conversions: assignment, promotion, and casting. Again, you don't have to worry about the particular names on that. And again, since we're mostly going to be working with ints, longs, and doubles, so you can take an int and you can widen it to a long or a double, and we do not use floats here. I can take a long and I can widen it to a double, again, without worrying, or I can take a float and widen it to a double, but since we don't use floats, we don't have to worry about that. Now, narrowing, again, like an int, since we're not using bytes and shorts and stuff like that, we don't have to worry about that. However, taking a long and narrowing it to an int is something which might arise. We are not going to use floats, but taking a double, we can turn it into a long or an int if we want. But now we can always widen, but when you narrow, you have to do something special. Okay, so one thing we can do is we can take a value and we can simply assign it to another variable of a wider value. So this is an example of that. So here dollars is an int, and we assign it to a double, and we don't need to do anything else because this can always be successful. The criterion is, can an assignment be guaranteed to be successful? In other words, in this case, this can always be successful because a double can always represent the double equivalent of an integer value or a long value for that matter. Okay, so now the money, the variable money is still a double. Once you declare a variable to be a particular type, you cannot change it to anything else. Okay, so promotion is something where you have an expression that involves 2 different types of things. And this is the most typical use case for this. So here we have a double value and we're dividing it by an integer value. Now, if these were 2 integers, then there would be an issue. But because this is because a double value is involved in this division, under the hood, it will convert count from an integer to a floating point value, which one it will, in this case, promote it to a double, and then perform the double division. And this assumes that the result itself is it has to be a double, by the way. If the result is not a double, if it's even a float or an int or a long, then the compiler will not allow this. Okay, the final way is that if you, and this is the one that I kind of prefer. And again, it gets back to programmer's intent. So, okay, so here we have an integer that's a variable here, and we want to divide it for whatever reason by another integer. Now, if we were doing this, it might behoove us to instead use 6.0 instead of 6. Okay, but we're not doing that. For whatever reason, we're dividing an integer by an integer, but we want to make sure that it doesn't truncate. So in this case, they're saying floats. I would prefer a double in any event. But okay, so here's what happens. This cast, this expression will take the total and turn it into a floating point value, 50.0. So this is now 50.0. And now when you divide that by an integer, it will promote the integer to a floating point and then put the result, in this case, in a float, which is legal. If you don't cast it, you lose the fractional part. However, again, this variable total is still an integer. That is still an int. It's this expression, the cast with the cast, that is a floating point. Okay, so the final piece is, and this is something that I'm going to ask you to do tomorrow, is this scanner class. And you've read about it. It's a convenient method for reading an input. And so if you remember, we've already seen the system out. And if you could think about it, if there's a system out, there ought to be a system in. And indeed there is. So this is how you do it. And this would be in your main method. And there's an example in the book. So this is how we instantiate things. And in your other programming languages, you've probably seen something like this. So the new operator says, I want to create a new object of this type. We are going to be talking about what this is about in a lot of detail. Okay, so the scanner requires kind of an input stream, and system in is one that's already created for you. What's nice about the scanner class is that we can actually use other streams. So these streams can come from your file system, or they can come from the network. They can come, and so what's nice is the scanner doesn't know or care where they come from. They just, all it knows is it's got a bunch of stuff coming in. So create the scanner object, and then we have various methods. Okay, so remember, objects have methods that we invoke. One of the methods is next line. That will read in the next line as a string. So it reads all the input until the end of the line is found, and you see the echo, blah, blah, blah. And those are all discussed. So here's an example. And NetBeans can kind of help you out with this. I see I'm not going to have time to do it now, but later this afternoon, I'll post a video that kind of walks you through how you can do all this within NetBeans. But okay, so here's where we enter a line of text. Okay, so we're going to create a local variable called message. It's going to be a string. Here we instantiate our scanner. We're going to now say, okay, here, enter a line of text. And then when we say the message is going to be the scan next line, that will read the line that we entered. And then notice that, okay, so there's our little example. Notice that we were using the escape character for the escape character to put the quote in. Okay, so now by default, at least, the scanner uses white space to separate these elements. They call them tokens. You don't have to remember that, but there are special methods called next int or next double to read data of a particular type. And here's an example of this, where if we look at here, it's saying enter an integer, and we read it in using next int. And then enter the number of gallons of fuel that are used, and then we scan the next double, and then MPG, which was defined to be a double. Again, this is not the way that I prefer variables to be defined, but MPG is a double, and so gallons is double, miles is an integer, so miles will get promoted to a double, and then this will actually give you the right answer. Again, way out to the bazillionth decimal place. Okay, so that does it for chapter 2. Hopefully most of this was review. Hopefully you have some clarity about what these data types are and how they operate and how they interact. In particular, the biggest gotcha is this sort of integer division.